My name is Beauchemin. I'll be presenting a product or a service that we offer to go from RDB to Postgres or Oracle and remain on OpenVMS. Okay. So, oh, it's this switch. Okay. We're going to be talking about why move in the first place. Then we're going to talk about how we do it. The data storage, the application considerations, and other items that we have. How many people here are on RDB? Okay, yesterday nobody was. Today is good. Excellent. Exactly. Well, that's good. Why move away from RDB? Well, I guess the number one reason is that it's very difficult to find people to support and manage it. People to support and manage it. They don't walk the streets all over the place. Okay. If you go outside and you say, looking for Postgres, anybody knows, and you'll get a whole horde of people. While the SQL Access is pretty much industry standard, there's a lot of other things inside of RDB that are not standard with the other databases, and it's its own environment, if you will. Future support, I'll just leave that as a question mark. Enough said. So the targets here that we're looking at, PostgreSQL. Right now, we suggest version 16, which is a fairly recent one, and it's got some performance improvements that have been added to it, and it's quite something. Oracle 19 is about the only thing that you can get to right now from OpenVMS using the 11 client. We'll go up to Oracle 19 on a Linux server, but that's it. Okay, you cannot go to 21 or anything beyond that. Of course, if you were to move the application later on off of VMS, go to Linux, then at that point you can go to 21 or 25 or all of the other oracles. So one of the things that we do at the beginning is to analyze the environment and then prepare the same equivalent, if you will, on Postgres or Oracle. So we look at the data storage, and for that we use the RMU output that you get. We analyze that, and then we can create a schema or a series of schemas that will fit your environment. One of the things that we see a lot of is that many applications that we work with have multiple RDB databases, and they work well. What we do when we go to Oracle or Postgres is we have one database with multiple schemas. So the RDB database is an equivalent of a schema inside of Oracle or Postgres. Okay. If you're using RDB right now, how do you access your data? Do you use SQL mods or embedded SQL?
I don't know.
I'm thinking here probably smoke signal, maybe. So there are basically two main ways of doing this. The SQL mod method is you have a series of procedure calls that are in SQL mod. It's a language, okay, from RDB. And you call them from your application. The application does a call to the SQL mod, and it gets the information back or pushes it the other way out. That's one of them. The other one is embedded SQL. This is where, if anybody use COBOL here, okay, you do exec SQL begin, and then you've got your entire SQL statement, and at the end of it, you have an end exec, and boom, that's your embedded SQL. You got host variables inside of there that pass the information back and forth. You do the same thing in C and C++. You can also do that in Fortran, and I think also, and of course, Pascal does it. Okay. Now, when you go off of RDB onto, let's say, Postgres, it gets a little more difficult because there is no preprocessor for COBOL or for Fortran, or especially not Pascal. Okay, so that is an issue, and we'll talk about how to do that. If you have if you're using SQL mods, that's not an issue, because at that point you're independent. The programming language is independent of how you're accessing the database. All right. So what we do for these guys, the COBOL, the Fortran, and the Pascal, is we will strip out the exec SQL and exec, and we'll put that into a procedure, sort of creating an SQL mod on the fly, if you will. And in our code, we'll leave the procedure head in the COBOL code, or the Fortran code. So your Fortran all of a sudden is no longer Pro Fortran, it's just regular Fortran calling these procedures. Okay, so at that point you have the flexibility of going to Postgres directly. If you were to go to Linux, there is a Pro COBOL for that, but we're talking here about staying on OpenVMS and accessing the Postgres environment. But since there is no Pro COBOL for it, you would have to strip it. But we have the tools to do that, and makes it automatic. And then, of course, as I said, the procedure calls, they're placed in line. So your code doesn't even know that it's doing it. You don't have to do anything to it. It just gets it done and replaces it, and you get a whole series of procedure calls. They get compiled by the C preprocessor for Postgres, and then you link and you go.
Now, it's right saying if Oracle do port the client to x86, then you'll get the COBOL preprocessor.
I don't know.
Yes, you would.
You would if they package it. But one of the things that we did for one of our customers in the not too distant future is in the not too distant past, Oracle stopped supporting Fortran as a language, Pro Fortran. So we had to strip out the code in Fortran and put it independently.
Basically creating SQL.
Yeah, exactly. So one of the things we do is, as I was talking about, is getting the RMU extract the output. We run it through our little parsers, and we create a bunch of schemas for all your tables with the columns and the indexes and all of those things in there. You can also transfer to views. Most of them will transfer directly. There's absolutely no problem. Triggers, that's a little different. Triggers, anybody here use triggers in their RDB environment? I've seen some that are pretty intensive. Okay, there are differences in the philosophy of how you fire the triggers, when they fire, and the order in which they fire. It's very, very similar, but there are some intricacies in there that you have to be aware of. We know what the tricks are, and you just rewrite them or touch them up, and it's not a big deal. One of the examples here is the RDB has multiple whens. Oracle and Postgres don't support that. So you have to have multiple triggers, with each have its own when, or you can simplify them. Stored procedures. Again, if you have some of them, we don't see too many people with stored procedures in RDB. It's much more of an Oracle or a Postgres thing, but RDB, they're very rare. And the ones that we've seen are the ones that are standard to do things that you don't need to even worry about, because they're done in Oracle automatically for you, or Postgres. We have seen code where in the trigger, they have a call to an external, like getting a logical, the value of a logical, and then they want to see, depending on what the value of the logical is, they do something in the trigger. That won't work, okay, because the server is separate. It is not on your VMS box where your application is. So what we did for that one is we sort of wrote a special table for that would get updated with the value of the logical that needed to be there, and then you just change that trigger. It's simple. There are many ways of doing things, but That was one of the tricks in there, is the fact that they were calling illogical. Once you've got these schemas, you want to verify that they will fit what you're looking for. There are some things that are different between RDB and the rest of the world. One of them has to do with dates. In RDB, all dates are stored as quad words, which is the number of milliseconds since 17 November 1858 at midnight. Okay. All of it works that way. Your application depends on that. So when you're doing date conversions or date calculations everywhere in your stuff, you have to have those numbers. So we have to, and of course, Oracle and Postgres know absolutely nothing of a quad word date. Okay. So we'll talk about how we do that. The other one is the tiny ends, the one word integers. And I've seen people be sneaky and slap a character in there, not just a number, but a character. And that's pretty nasty. So we have ways to deal with those things. They're rare, but they're there, and you need to be aware of them. Data overloads. If you write in COBOL and you read a record, like say X250, sometimes, depending on what the first character says the record is, you get a different interpretation of the data. And then, of course, RDB is not doesn't check the data. So you can slap binary data in an X field. And Oracle and Postgres do not like that. So all of a sudden, if you're slapping in an X250, and if the first character is this, these are dates, these are dollar values, and this is a character string, or the other way around and everything, that's going to be an issue. But there are ways of doing that. So as long as you know what it is, there's a method in Postgres and Oracle where you can actually identify that and say, give it to me as raw. And then I'll take it and I'll figure it out. And that's what you need to do. Okay. So all the dates in Oracle and Postgres, they will be the standard date. And that's, whatever the format is, whether you have it with the full date and time or the time zone or whatever. And then in RDB, it's in quad word. So what we do is when you're retrieving the data from the database with your SQL mods or your embedded SQL, we convert the date that's in Oracle or Postgres format in the database and give it back into your host variable as a quad word. So your program doesn't have to worry about it or do anything about it. It just gets the date as it is. And when you store it back into Oracle or Postgres, we detect that and we convert that quad word into an Oracle or Postgres date string. So that's what we do there. Back and forth. We also rationalize some of the schemas. Well, we don't do that. This is something that you have to do on your own. If you decide that maybe you don't need this type of table anymore, something like that. We've seen places where they have 400 tables and 340 of them were empty anymore because they weren't doing anything with that. That went over by the wayside. So maybe they want to trim them off and not have them there. We talked about multi-DB paradigm, where RDB, you have multiple databases open from the same program. Oracle and Postgres really like to open one database and have multiple schemas. The big thing with that is that if you're doing multiple database transactions, Oracle is going to have an issue if you're crossing Oracle boundaries. Postgres is the same thing. But if you keep everything within the boundary of a database and just go across schemas, everything works fine.
Not the rollback.
It's the commit and the rollback. Yeah, exactly. So we do that. This is something that when you're doing the transfer of the schemas and everything, you want to give it some thought and make sure that you're doing exactly what it is that you're expecting to do. So moving the data, this is the fun part. Again, you use RMU for that. And one of the things that you'll do is you're going to be extracting all the data out of every table, and it goes into a single file. And then the file will also have a control file that tells you where the data is inside of your table and what it represents. And not inside the table, inside the record, and what it represents. All the numbers are extracted in ASCII, and the dates as well. They're expanded into that. You don't get a quad word. You actually get a real date when you do the extraction. You go through, make sure that your control files match, that everything is good, so you've got everything extracted. Transfer the files over to wherever you have a connection to the Postgres database, and actually it would still remain on VMS, so you don't have to worry about it. You extract them on VMS, leave them there, and then just upload them.
What about binary data?
The binary data, it gets, as I said, everything is ASCII. It comes out as ASCII. Okay, so your values, your numbers, the dollar amounts and stuff like that, or the money and everything, it all comes out as ASCII characters, and it's interpreted that way. And then the PG loader or SQL loader will take it, recognize what it is, and then just bundle it up and put it back into a numeric or a decimal.
Yeah, but what if the source was binary?
The blob.
A blob. Or
A blob,
or it could be
there are ways of doing that. I haven't had to deal with a blob. They're very rare. They're very the ones we have not seen it. I mean, we did IKEA about 5 years ago. All their system, they had 450 tables and 700 SQL mods, files and everything. It was just a massive amount of everything, but no blobs. Do all of you, any of you have blobs?
Only for testing purposes.
I'm sorry?
Only for testing purposes.
Okay, very good. I don't want to talk
But,
about it.
I mean, it's a
Yep.
question, Norm.
Yeah, but you can
If you do an RMU,
binary.
you know, if you unload a table and sort of segmented string in it, what happens?
So in RMU, plain normal RMU, it just stores it in an unload file in the internal format. I can't imagine what you would get if you just said, give me a blob, because they're almost by definition unlimited.
Exactly.
Unlimited format.
Yeah.
There's a whole class of really hard problems in this space. And the easy, simple example is you have some character string, put it in what you want, everything works fine until there's a null in the middle of it.
Yeah.
And now you wish to hand it to some modern system where null is special.
Exactly.
There's special handling required. There's not, in my experience, having done this a couple times.
Yeah.
There's no one answer.
Oh, no, absolutely not. This is something you may have to write some bespoke programs to do to deal with that and transfer it or pull it from there and stick it into here or whatever. Things like that may happen. I just talked about some of the more common ones that we found, the tiny ints, the dates, and the overloaded data set, and things like that. Those are pretty standard and can be handled pretty straightforward, even though you got to be smart about it and make sure that you're dealing with it. But the blobs, I'll leave it to you. Yeah.
But I'm just thinking with the character call database.
Yeah.
You could typically store any characters when you start unloading them.
Well, and that was my point earlier when I said that Oracle and Postgres or data integrity is key. You cannot put a binary character or something that in an ASCII string. It's not going to go for it. It'll give you an error. It's a 1023 or something like that. It basically pukes on you. I said, you don't do that to me. Okay.
Is that an acronym, that puke?
Yes. Yeah, it's pretty useful, knowledgeable expansion. Okay, but it really, and that's actually how we discovered it. And all of a sudden I'm looking at the code and I'm saying, what the hell are you guys doing? And then they have different interpretations depending on the first character of the string.
Why have a database?
Yeah.
RMS.
What's the other one?
Well, most of them, of course, is consolidated multiple RMS files, just,
I mean,
of course, it RDB.
yeah, talk about defeating a database, just put in random crap. Okay. So you copy the file to the target, but in this case, it remains on VMS. And then you may want to adjust the control files. Sometimes there are some things that you may want to check into. Pretty straightforward. But what we do is we build scripts to make sure that we handle it. And then you've got calculators at the end to make sure that you've got all the records that you think were going to go in there. And you may even have some things where you do checksums to make sure that everything is straightforward. And then you load the data with SQL loader or PG loader, and it just loads it up. And you just drive it with your scripts, and you watch it go by. Now, one thing is after you've loaded your data, gather the statistics. Make sure that your database knows that it now has 1 million or 2 million records in the table or something like that, because the access method from Oracle or Postgres depend on the number of records that it knows that it has in there. So if you didn't gather the statistics, it always thinks that your table is empty and it's going to be slow. For the multiple RDB database into one Oracle or Postgres, what we do is because the application on VMS has a user that opens a database, what we do is we create a user for each of the databases to match what your environment has, your program has, okay? And then after that, you make sure that you grant the access to these users so that they have access to all the schemas that you have. So at that point, you're going to be able to have one program, the way it works right now, exactly as it is, be able to access all your databases without changing anything in the code. Okay, but you do all the magic inside of the Postgres or Oracle database.
And also, the one place this does kind of fall down is ACMS, because ACMS has the ability also to roll back transactions, and ACMS won't communicate with Oracle or Postgres.
No.
So if you've got ACMS, it has a certain complexity to this whole thing. That has a lot of complexity to the whole thing.
After that, you want to transfer the stored procedures, if any. I already said we've very, very rarely seen stored procedures. Triggers we see a lot, but stored procedures are very rare. But don't forget them. If they're there and you're using them and they're not in Oracle or Postgres, make sure that you transfer them. And also look for system calls inside these source procedures. They may have something that says, go see what this logical is. Okay. So here I'm just showing a little graphic on how we do this. Depending on the access type, if it's SQL mods, we have programs that will transform your SQL mods into what we call SQL PGCs or SQL PCs. And they're essentially C code with embedded SQL that mimic what an SQL mod do. And they have the same interface in and out, or the API to the program. So your program doesn't even know that it's running C or going to Oracle or Postgres. It just thinks that it's a regular SQL mod.
And this is the place where we do the conversion between the datetime format.
Yes, the datetime format is done in there. Yeah, exactly. Everything is built in there. It knows all about these things. It detects it and takes care of it for you.
And that's a product. So that is
Yes,
that is a press button. Put in
that exists and that's there. Yeah.
C embedded for Postgres or Oracle.
And then after that, what you do is you compile your application as usual, except that you don't push it through the preprocessor. If it was embedded SQL and now it's taken out of it and it's an SQL mod, you don't go through the preprocessor anymore. You go directly to the compiler. And then you link them and you're ready to go. If it's embedded SQL, what we do is If it's in C or C++, we can handle it. I mean, there's ECPG is there. It will take it, it will pre-process it and compile it and do everything. If it's COBOL or everything else, then you use our other tool that extracts the SQL blocks from your code, prepares it into a separate file, one per big program, if you will, with all the procedures in there, the calls and the APIs. And then in the source program, we just put in the calls to that. So your program, instead of saying exec SQL so-and-so, it just says call this procedure and get the information back. Okay.
Well, we turn embedded SQL basically into SQL mods.
Yes, that's exactly right. Now, one of the things that a lot of people do is when they do an exec SQL, they will do a select star. These people should be shut. Okay, because if ever you modify the database, add a column or do anything in there, your program just explodes because it no longer fits what it is. It also has the other fun thing that we are no longer able to do the date conversion, the automatic date conversion, because in SQL star, that's your select list and it's very small. So what we did is we have a program that takes these and generates an expanded SQL select list. And then it does the calculations that are required for the date strings. It's all built in, except that when you put that in your COBOL or in your C code, all of a sudden your 3-liner exec SQL select star into this looks like. So what we do is we hide that, and you only get to embed that file just before you start the preprocessor. So you support your program as usual, and you have that file that's there for you.
And certainly there's an optimization we can do once you see the expansion.
Yeah.
Something you want to optimize.
Absolutely, yeah. So yeah, people say you just go ahead and do a select star, or even worse, do a insert everything. Did insert everything, and just name pass all the items in there. And of course, we have to be able to decipher the dates and do the transfer the other way. So we take care of that. And if you have it in your C code, it will remain in there. If you have it on COBOL and there's a COBOL preprocessor that's available for that, it will remain in there the way it is.
Fortran. We get a lot of Fortran with embedded SQL.
Yeah, but there are no preprocessors for Fortran.
Right. But nor is there for COBOL.
Yeah. I understand. So there are some for COBOL, there are none for Fortran. There's C has them all. Okay. And then after that, so we pull out the procedures, we put them into an embedded, the embedded SQL is pulled out from the source. We place that into the equivalent of an SQL mod. We have the procedure calls in the source code.
And we map all the host variables, of course.
And the host variables get transferred, yeah. And then after that, we just compile everything. Your pro COBOL is no longer pro COBOL, it's just regular COBOL calling these procedures, or your Fortran or your Pascal or whatever. Okay. And then we run through the newly created SQL mod into what we call an SQL PGC. That's pre-processed, everything is ready to go. And we link it with the application, and your executable is ready to go at that point.
You're going to talk about the optimizations?
No. We may. Let me just follow this. Okay. So what we're doing here is when we were doing the migration of SQL mods to SQL PCs or SQL PGCs, we wanted to be able to test these SQL mods. And as you know, when you write an application, getting to a certain call in your program can be very difficult, very convoluted. By the time you get to there, it's a special situation, this, that, and the other thing. And it gets very difficult to be able to test it. So what we do is, because we have all the information about the call and we've got the procedure head and the return codes and all that stuff, we, for each SQL mod file that we create, let's say maybe it has 20 or 30 procedures inside of there, we create a program, a C program that drives the SQL mod. So you can actually tell it to do something, open a database, go get this record, execute that specific procedure, the one that you want, okay, the one that you could never test because it only occurs on the Friday after a full moon or something like that. You're able to do that at that point. You get timing information and you get all the information about the call itself, how it went and all that stuff. So this way, you can test all of your procedures, test all the corner cases, all the ones that you can never get to in reality. And you also get a feel for how the performance is going to be. And if you need to do anything to accelerate the performance, then you know which ones that you can go after. And of course, you can script all this and then do a full test, full regression test every time you do the procedure, the transfer.
Particularly nice when the only moving part really is the SQL mod or the equivalent of the SQL mod. The code is pretty much unchanged.
Yeah, the code stays unchanged and on VMS. Absolutely.
We don't change the line of application code, just extract the SQL or use the SQL mod. It's very nice to be able to.
And the other fun thing is that instead of you linking the program, the test harness with our SQL procedure, you can link it with the SQL mod, the existing SQL mod, and test that at the same time. So you can compare. This is my little test case with the SQL mod on this one. This is my little test case with the SQL PGC on this table, same place, and then you can check, verify that everything is working.
Typically, what, see 300-400 SQL mods in a normal application?
I don't know of any normal application. The ones we've seen is like 600, 700 SQL mods that may have 100, 150 procedures inside of them. Others, there's going to be a much smaller group of SQL mods, but they are much more extensive, far more powerful. They were created especially for, this is how you access this data. All programs will use that one, okay? Whereas a lot of other places, it's each program has its own. So that's where you go. You can have very few with lots of procedures with joins and, you know, hundreds and hundreds. I've seen one that was like 420 lines for a select statement in an SQL mod. And I mean, how do you debug that? But you know, you pass it through this, you got the test harness to do that, and then you see if it works. Okay. But those are there. The vast majority are going to be very simple ones. Okay. Now, one of the things beyond this, go a little back here. One of the things that we'll see with the test harnesses is you can detect to see if there's a problem in terms of performance. And my lovely assistant here reminded me. Okay, so there are things that we can do to accelerate. It's called prefetching and block fetching. So in the case of if you do cursors, you declare a cursor at the beginning, okay, and then after that you do fetch. Some applications are long ago, 20, 30 years or more, and they are not really SQL-ish. They're more like RMS that were slapped into RDB, and you're going through. So you're looking at the invoices for today, but you're going through a table that has invoices for the last 2 years, and you're only looking for the ones for today. So you're reading all of them.
Get next.
Get next. So what we do is we are able to actually detect that, and in the SQL mod, accelerate this by going out and saying, go ahead and get me 5,000 of these and put them in a big block, and then ship me that block across. And then internally or locally, I just go through the block and just give them to you one at a time. When I'm finished, I get the next 5,000 and things like that. So that's how we accelerate with the prefetching. We can do that in Postgres and we can do that in Oracle. And when you're going over a network, because you will be going over a network on this, it's important to have that to make efficient use of the transfer.
It's pretty clever. That is an order of magnitude change in time.
Oh yeah, that made a huge difference.
Yeah, I mean, tens of minutes down to
Yeah.
seconds.
Exactly. So IKEA, as an example, they had their VMS systems on site, and right next to it, that little Linux system with Postgres on there. And they just they ran the application on VMS, talking to the Postgres database, and it actually ran faster than when it was all on one system with RDB.
Get next.
Exactly. Those things, they were able to get beyond that. Now, of course, the ultimate answer would be to do something in the code to say, oh, just say to SQL, give me the addresses or the records for this date. Be discriminating, let the server do that. And then you don't have to change the code. It's just all of a sudden, all the records that you're reading are valid. You're not throwing away 99% of them. All the ones that you're getting are good, and it goes fast. And I did that for one customer several years ago, and something that took an hour to run normally went down to 5 minutes, and they said it's broken. I said, no, it's not. You're not reading 2 million records and throwing away 1,990,000. You're just reading 20,000 records, and they're the exact records that you want.
Of course, as you know, all this code was written, what, 30, 40 years ago?
Exactly.
We've got the RMS files were integrated into an RDB database, and still the get next is just the way the
way you did it. So flow diagram here for COBOL. You got your original Pro COBOL. We've got the embedded to SQL mod, EMB2 mod. Okay, that takes out and it pushes code on the one side that's going to have no SQL in it anymore, but it's going to have the calls, the procedure heads there. Okay.
And this would be for Fortran, Pascal. Code.
Well, there's going to be one for each of them, yeah. But this one exactly right. So, and then you got the generated PC file, and then you run it through ProC or ECPG, whichever one it is. If you're on Postgres or whatever, you compile everything. You got your object code. You link them together, and you get your executable. Okay, except the executable, you didn't do anything to the code really. The logic of the code, everything that was built into the code, you didn't touch it. We just replaced the exec SQLs with procedure calls, and it works the same way.
And you could you could actually do this yourself and go through and make your own SQL mods first, then translate the SQL mods.
Oh, absolutely.
Or you just do the automatic embedding to SQL mods.
Yeah.
Unfortunately, there's no preprocessors for, well, Oracle has a code preprocessor, no Fortran, no Pascal.
No, nothing else. Yeah.
Postgres only has for C and C++.
Yeah. And then for Fortran, actually, that was the first one where we did this because Oracle dropped the Pro Fortran in Oracle 12, and they had just gotten to Oracle on Linux, and then all of a sudden discovered that, oh, that was gone. So we wrote this procedure, and it worked really well. It just strips it out and does it and pushes it back out again.
And maps the host variables, passes them all the right things, and does state conversions.
Yeah. Everything is automated.
Conversions is a big thing. I mean, out of everything that we do, it's detecting and obviously converting the data back to quality words and back.
That is critical. If you can't do that, you don't have anything. Okay. You'd have to rewrite your entire application at that point. And especially if you got intervals and things like that, date and time and all that. Yeah. So that's a Fortran, and Pascal is the same thing. We can do that. We just extract the SQL.
We don't see a lot of Pascal.
Hmm?
We don't see a lot of Pascal.
Well, our friends at IKEA were Pascal.
Oh,
Yeah. Now that you're off of RDB and you're going on with Postgres or Oracle, is that you got a lot of people that you can find to work with Postgres. Everybody knows Postgres. There are a lot of tools that are available that will deal with Postgres. And since it's on a separate server, anybody in your enterprise can have access to it. It's not just a closed soft system on its own server. It's part of the enterprise, and VMS now is sharing its information with everybody else openly, and you can have all the other fun tools that come with that. And there's a whole lot of tools.
And thanks to Brett for migrating Postgres.
Yeah,
Pleasure.
yeah, it was very good.
Slide, at least.
Yeah. So now it's very much an industry standard. We're up, when we first started with this, it was Postgres 8. And now it's 16 is out there. And it is, the performance has just expanded and accelerated, and the coverage is great. The future support is assured. Postgres is going to be here for a long, long time. There are a lot of people on it, and it just keeps growing very rapidly. And at that point, you've achieved your target. You are now still remaining on OpenVMS, but talking to the RDB, to the Postgres database on the other system, and everybody else can share in it.
Postgres has got one big advantage over Oracle, and that's it's free. Which
Yeah.
A lot of people like
Oracle
that.
stuff isn't.
Oddly, no.
No. Oracle charges a lot. Yeah, absolutely. Are there any questions? Yes.
Sure. So one of the challenges, I think that's too strong a word, but the locking semantics within a transaction on RDB are what they are.
Yeah.
The locking semantics, either by default or even available on some of the other platforms, are not the same.
They're completely different. Yeah.
The struggle of applications relying on certain kinds of serialization behaviors, between to read-write transactions and so on.
Yeah, those are things that you have to address, but that's a very good point. What we have found is that Oracle does a great job of managing its locking on its own. If you try to interfere with it and say, I want force this or stuff like that, you're going to create problems for yourself. So you're better off not doing anything like that. Same thing with Postgres, okay, especially with version 14, I think there was a big change, and 15 really got it going, and 16 now is just, it's slicker than snot. It really goes well.
Another acronym.
Yeah.
But you're absolutely right. I mean,
Yeah.
we deal the cases we see, they don't do a lot. I mean, I'm sure you obviously see a lot more than we do, but typical commercial application, we don't see a lot of crazy stuff. But it's going to have to be addressed.
Fundamentally, there's no silver bullet, right? So what you're saying here is, it might get you 90%, might get you 95.
95, 98%, but there's always going to be the odd thing that you have to deal with. Yes.
And where you see the struggle, I mean, when we migrate applications like this, is the default behavior in RDB is when you read a record inside of a read-write transaction, record's locked. None of the other databases do that.
Oh, that's not true. When you start a transaction, as soon as you do, it starts locking behind you as you're going along. It locks up.
Okay, so
Yeah.
what you're saying is, on Oracle.
Yeah.
I say set transaction read-write, I fetch a record, nobody else can modify that record until I commit.
Well, it's going to be, my environment is going to be there because I can do a rollback. And everything goes back to the way it was if I had to do that.
They haven't modified.
Okay, they haven't modified.
I haven't modified.
That's right.
Can somebody else modify it?
If they modify it, they won't be able to commit it until such time as you finish your transaction. Yeah. Oh, that's exactly how it works, which is why I'm saying is that there is no such thing as start transaction on Oracle. Really, there isn't. It does it as soon as you do select something or whatever, just any type of data manipulation, DML, it starts locking, and it locks behind you as you're going along. Okay, and that's why you never want to have long locking transaction. Like, don't do a lock over a terminal read or something like that, or just keep it moving along. But it will not change on you until you do a commit, and then the other person can see his own transaction, but it will not be committed until that person does a commit, and it won't commit until the other one is done its commit if there's things in front of it. if there's things that already were locked. Yeah, and that's why I said Oracle and Postgres do a great job of doing this, and you don't want to micromanage them. Okay, so what we do is for the vast majority, we just ignore the calls to locking. Yeah, just completely ignore them.
In a very sophisticated way.
And yeah, absolutely, because Oracle does a fantastic job of doing this, and Postgres does the equivalent as well. Now, if there's something very, very specific that you need to do, then you would have to go digging. But we haven't seen it.
There's always going to be edge cases, there's always going to be things, but we can get 95% of the way there. With IKEA, it was 100%.
Yeah.
We didn't have any lift locking issues whatsoever.
Never.
Within the Oracle environment, when the third process comes and says, I now want to read the record that the second guy said he's modified, well, the first guy.
That's when you start getting into that. Now, if it's the exact same record, then you're going to have an issue and there's going to be some weighting behind it, okay? But if you're looking at another record, and what are the chances are if you got multi-million record databases and everywhere that, you got 3 people going after the exact same record to modify, of course it's going to happen, but it usually doesn't.
Right, the sequential counter.
Yeah.
Last balance of the customer.
I understand, but Oracle and Postgres handle that. They do it.
I mean, all three database engines do isolation levels by default
Yeah.
in different ways.
Yeah.
And the behavior is significantly different
Mhm.
between those 3 engines.
I get that. I totally agree, but I'm telling you that in our experience, if you try to go in there and try to emulate or introduce things in there in Oracle or Postgres, it's going to be worse than if you just leave it alone. Okay, and IKEA was one that it was done just a few years ago. We never bothered with any of it. We just completely ignored it. And it's running on 450 stores all over the place. And they don't have those issues. Allianz.
Of course, 2 people can't buy the same bed at the same time.
On the same invoice number. Okay. And also,
I think we're done today. I think our time slots up.
Oh, we are? Oh, that's why she's pushing me. Okay, I'm sorry.
He gets he loves doing this.
Yeah. No, but really, if you want to go hunting for issues, go for it. And I was going to suggest that you go play with the locking. That's a great place. Okay. But if not, I mean, the vast majority, the very vast majority is going to go right through. But you do have to look out for the tricks. And that's what I was hoping to point out, some of the various ones that we have in there. And we're always happy to discuss it with you as a project or just for information. You've got the thing, the slide is, the deck is on there. Okay. So we're good. All right. Any other questions? Thank you very much.